All right, simplifying radicals. Here's the rundown. You take the radicand, that's the number inside the radical. Radical is the actual square root symbol. Square root of 24 is not a whole number, so we don't want to estimate and say 4.9, blah, 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 because that would go on forever. We don't want to lose the accuracy or the precision of that number, so we're going to simplify it instead. The way we simplify is we have to find all of the prime factors of 24. So we make this prime factor tree. 6 times 4 gives us 24. These numbers are not prime, so we keep going. 6 is 3 times 2. Those are both prime, so that branch is done. 4 is 2 times 2. Those are both prime. So we are done with our factor tree. We got 3 times 2 times 2 times 2. What we look for here is pairs of numbers. I have a pair of 2's here. If I have a pair of numbers, that brings a 2 outside of my radical, outside of my square root. The single numbers, in this case 3 and 2, which multiply to give me 6, stay in our radical. Now the reason for this is actually the square root of 3 times 2 times 2 times 2. Well, 2 times 2 is 4, and the square root of 4 is 2. The square root of 6 cannot be simplified, so that's why it stays in. Let's look at a few more examples. We have 75. 25 times 3, and then 5 times 5. It doesn't matter what route you choose to do this factor tree. You could have done 75 is 15 times 5, and then 5 times 3. Either way, you're going to get 5, 5, and 3. The order might be a little different, but the numbers are all there. So, pair of 5s brings a 5 outside the radical. 3 stays in. So 5 root 3 is our simplified version there. Let's look at 4 more examples. 28 is going to be 2 times 14. 14 is 2 times 7. So a pair of 2's, and the lonely 7 stays in. So 2 root 7. I'm going to erase that to give me some space here. 105 is 5 times 20 is 100. So that's just one more 5 after that. So 5 times 21. 21 is 7 and 3. So here we have something unique happen. Our prime factors are all different, 5, 7, and 3. There are no pairs, so that can't be simplified. It just stays the square root of 105. It's already fully simplified. 3 root 72. We're going to simplify the root 72 part. What do we got? 9 times 8. 3 times 3. 4 times 2. 2 times 2. So the pairs of numbers. Pair of 3's brings a 3 out. Pair of 2's brings a 2 out. We already have a 3 from the problem that comes out, and then lonely 2 stays in. So now when we simplify this, 3 times 3 times 2 is 18 root 2. One more. 384, this is a big one. 2 times, let's see, half of 384 is 150 plus another 34, 380. So 1, what's half of 384? This is when the calculator comes in, or I should have, there we go, 192. All done in my head. Half of 192 is 96 times 2. Half of 96 would be 2 times 48. We're going to have lots of 2's here. I'm going to do it different. 6 and 8. 3 and 2. 2 and 4. 2 and 2. So let's see if we can look at all of our factors here. 2, 2, 2, 2, 2, 2, 2, 3. So we have 7 2s. There's a pair of 2s. That gives me 1 2. Pair of 2s gives me another 2. Pair of 2s gives me another 2. And then single 2, single 3 is 6. So 2 times 2 times 2 is 8 root 6. And that is simplifying radicals. Where's my mouse? Pause it. How do I pause it? There we go. All right, the next part here we have rationalizing the denominator. Rationalize the denominator. So, with square roots, it is not simplified if you have a radical as your denominator. So while this 7 over root 3 looks nice and pretty, it is not. We have to fix it. So, here's how we do that. We need to multiply something to this fraction that gets rid of the square root on bottom. If I multiply the bottom by the square root of 3, then my new denominator becomes the square root of 3 times the square root of 3, which is the square root of 9, which is 3. So that rationalizes the denominator. The problem is we can't just multiply the denominator by something because it changes the whole value. So this here needs to be a very special number that doesn't change the value. That special number has to be 1. So I need this whole circle to be 1. The only way it can be 1 is if we have the same thing on the top as we do on the bottom. So square root of 3 divided by square root of 3 is 1, which makes it okay to multiply by, because we're just taking 7 over root 3 times 1, so it doesn't change it. That makes our numerator now be 7 times root 3. So my simplified version is just 7 root 3 over 3. That is simpler than this. Doesn't really look it, but it is. Trust me. 2 over root 300. Again, we have to multiply by this special fraction that is 1, which is going to be root 300 over root 300. On top, we have 2 root 300. On bottom, we have root 300 times root 300, which is the square root of 900, which if I square root that, is 300. No, not that, it's a 90,000. I was off by a few zeros, which is 300. So now we have a rational denominator. The problem is this root 300 is not fully simplified. Actually, I can do quite a few things to simplify this. So we have to continue simplifying down here. 2 root 300 over 300. The square root of 300 I can simplify the way we did last week. So 300 is going to be 3 times 100. 100 is going to be 10 times 10, which is 5 times 2, 5 times 2. So pair of 5s, pair of 2s, and then single 3 stays in. So 10 root 3 is the same as root 300. So right here, I'm going to replace root 300 with 10 root 3. That gives me 2 times 10 root 3 over 300. I can now simplify this sum because 2 times 10 is 20 root 3 over 300. 20 over 300 can simplify to 1/15. You can cancel a 0 out. That's 2 over 30, which is 1/15. So 1 root 3 over 15, and the 1 is not necessary. So that is our simplified answer there. Crystal clear, right? Let's look at another 2 examples. Times our new fraction that has to be 1, which is just root 5 over root 5. On the top, we have 15 times the square root of 5. On the bottom, we have the square root of 5 times the square root of 5, which is the square root of 25, which is just 5. The square roots just go away, and you're just stuck with 5. That's the whole nice part of this whole process. 15 root 5 over 5. I already know the square root of 5 can't be simplified because that is prime. There's no prime factoring I can do, but I can simplify 15 over 5. That gives me 3 root 5. 8 over root 32 multiply. Actually, I want to do a different example. I want to speed this up. Do I have any? No. Never mind. We'll do this example here. Nope. Back to 8 root 32. Root 32 over root 32, which is 1. 8 root 32 on top, 32 on bottom. 8 over 32, I can go ahead and simplify. I know that is 1/4. So 1, let me rewrite it over here to give me room. 1 root 32 over 4. But root 32 is not simplified. So my next thing is to simplify root 32. Which is 16 times 2, 8 times 2, 4 times 2, 2 times 2. So, pair of 2's, single 2, single 2. So 4 root 2 is the same as the square root of 32. So I'm going to rewrite this as the 1 can go away. I don't need that. 4 root 2 over 4, which the 4's now cancel out. So the square root of 2. I like that problem. It comes out so pretty. That's about it. Good luck. I think you can handle it. If not, you'll figure it out. Why does my mouse just disappear? Goodbye.